equation, we want to resolve this compound fraction into partial fractions. Actually, we don't have any method to use, so we are free, we are at liberty to use any method of our choice. With that said, I will try as much as possible to use the simplest method, so I hope you catch it. Now, looking at this denominator, this is actually a quadratic expression. X squared minus 9 is a perfect quadratic binomial, which this very expression I can rewrite as 2x squared minus 3x minus 10 over x plus 2. So this perfect quadratic binomial can be written as x minus 3, x plus 3. And if you like, you can put x plus 3 at the front and put x minus 3 at the back. They are still the same thing. So with this, let us resolve this compound fraction into partial fractions. Now we don't have anything quadratic. Each of them stands alone here, so that will give us a over x plus 2 plus b over x minus 3 plus c over x plus 3. So what do we do? Just look for the LCM. The LCM will still remain what we are having here, which is x plus 2 and then x squared minus 9. Now when this one goes into this, we'll be left with this. So we have a into bracket x squared minus 9, then plus, when this one goes in the two of them, this, we end up cancelling out the x minus 3 that is present in this. So we have it as b into bracket x plus 2 and then x plus 3, then plus c. When this goes in what we have in here, we'll be left with this 2, which is x plus 2 x minus 3. Then the compound interest that actually equals that, let's quickly write it out, is this x plus 2 x minus 3 x plus 3. Now we can say that 2x squared minus 3x minus 10 is identical with the numerator. So with that, let's use this a to open this bracket. That's going to give us a times x squared. That is ax squared. I want you to follow me carefully. A times minus 9, we have minus 9a. Now, what we need to do, let's quickly open this bracket here. X times x, that is x squared. X times plus 3, that is plus 3x. Plus 2 times x plus 2x. Plus 2 times 3 plus 6. So that we are having x squared plus 5x plus 6. Now use this b to multiply what we have here. That will give you plus bx squared, then plus b times plus 5x plus 5bx, then plus b times plus 6 plus 6b. What we did here, we also quickly repeat it here. Now I'm having, for this one, we'll be having x times x, that's actually x squared, x times minus 3 minus 3x, plus 2 times x plus 2x, then plus 2 times minus 6 minus 6, plus 3 minus 3 plus 2x, that is actually minus x and minus 6. So this is what we use our c to multiply. Now c times x squared plus cx squared plus c times minus x minus 6x, then plus c times minus 6 minus 6c. Don't forget I told you, we have not been told to use any method, so we are at liberty to use any one that we like. So what we want to just do is we'll be using method of comparing the coefficient. Now we have 2x squared minus 3x minus 10 equals, so let's bring the square, those that are having x squared together. So here I have ax squared plus bx squared, then plus cx squared. Then the ones with x, I have plus 5bx. Which other one again? Minus cx. Then the ones without x, I have minus 9a. The one without x plus 6b. The one without x minus 6c. So having said that now, let us try to compare coefficients. The coefficient of x squared here now is 2. So I will say 2 equals, coefficient of x squared here is a. A plus, the coefficient of x here is what? X squared. B, then plus c. So you call this one equation 1. Now the next thing is coefficient of x. The coefficient, this is x. The coefficient of x here is actually minus 3. So minus 3 equals, now let us look at this side now. Coefficient of x, I have plus 5b. Plus 5b can be written as 5b, then minus c. Minus c. So this is equation 2. Then for the constant here is minus 10. Minus 10 equals constant. So here now, without x, I have minus 9a, minus 9a plus 6b minus 6c, equation 3. So the next thing now is to solve equation 1, 2, and 3 simultaneously. So from here, we can make c the subject of formula. So let's make c the subject of formula in equation 2. Make c the subject of formula in equation 2. Make c the subject. Make c the subject in equation 2. So from there now, all we need to do is, let's just take our c to this side so it becomes plus. Then we bring this one to this side. That's giving us c equals 5b plus 3. Equation 4. Now this is our equation 4. We will now put it into equation 3 and equation 1. That is, anywhere we see c, we have to write 5b plus 3. Now from equation 1. From equation 1. Our equation 1 looks like this. 2 equals a plus b plus c. But don't forget, our c is the same thing as 5b plus 3. So we have it as 2 equals a plus b plus 5b plus 3. So bring this 3 to this side. We have 2 minus 3 equals a plus 5 plus b. Plus 5b plus b plus 6b. Now 2 minus 3. This is minus 1 equals a plus 6b. And this is our equation 5. The next thing we have to do is, we also make sure we put the value of c in this equation 3. Now we have from equation 3, we are having minus 10 equals minus 9a plus 6b minus 6c. Now minus 10 equals minus 9a plus 6b minus 6 into bracket our c. Anywhere we see c, we have to write 5b plus 3. Minus 10 equals minus 9a plus 6b minus 6 times 5b minus 30b. Minus 6 times plus 3 minus 18. Very good. So this minus 18 is coming to this side. We are having minus 10 plus 18 equals minus 9a plus 6b minus 30b. That will give us minus 24b. Minus 10 plus 18, this is 8, equals minus 9a minus 24b. Equation 6. The next thing now is we'll be solving equation 6 and 7 simultaneously. So solve 5 and 6 simultaneously. So let's place them side by side. Here's the 5. We have minus 1 equals a plus 6b. Then we have 8 equals minus 9a minus equation 6. With that, let's quickly, I think there's one we cannot cancel out, but let's cancel out b. So I will multiply this by 4, I'll multiply this by 1. 4 times minus 1. My 4 times minus 1 is giving me minus 4 equals 4a. 4 times plus 6b plus 24b. When we use 1 to minus this, it will not change. 8 equals minus 9a minus 24b. So this we cancel this out. That's when we solve vertically. Minus 4 plus 8. This is 4. 4a minus 9a. That is minus 5a. So you divide both sides by minus 5. Then our a equals minus 4 over 5. Now let's try to look for b. We put this value of a in either equation 4, 5 or equation 6. So from our equation 5, our equation 5 looks like minus 1 equals a plus 6b. So minus 1 equals a. Anywhere we see a, we have to write minus 4 over 5, then plus 6b. Collecting like things, we have minus 1 plus 4 over 5 equals 6b. Now, minus 1 plus 4 over 5. Minus 1 is actually greater than 4 over 5. Then all we just need to ask ourselves is, this is the proper fraction. What am I going to add to 4 to give me 5? That is 1 over 5. And because 1 is greater than 4 over 5, the answer is going to be negative equals 6b. Then what do? We multiply both sides by 1 over 6. 1 over 6 times 6b. So this is here 1, 6 here 1. I'll be left with b equals minus 1 over 30. Now, my a is this, my b is this. Remember that our c, that's from equation 4, which talks about c. C equals 5b plus 3. Now c equals 5 times, what did we get for b? We got minus 1 over 30. Minus 1 over 30 plus 3. So c equals 5 here 1, 5 here 6. We are having minus 1 over 6 plus 3. We can rearrange this as saying c equals 3 minus 1 over 6. Remember, this is a proper fraction. How do I need to solve it? Let's split this 3 into 2 plus 1. So this one, we'll use it to undo 1 minus 6. So c equals 2 whole number, 1 minus 1 over 6. This is a proper fraction. What will I add to 1 to give me 6? That is actually 5 over 6. Now, I will still prefer to write my c in improper fraction form. So 6 times 2, 12. 12 plus 5, that is 17 over 6. Therefore, our fraction, our compound fraction is, which is 2x squared minus 3x, that's this very problem. We bring it down to the front. We have it as 2x squared minus 3x minus 10 divided by x plus 2 x squared minus 9 equals, we have it as a over x plus 2. What did we get for a? A is minus 4 over 5. Minus 4 over 5 then over x plus 2 plus b. This is minus 1 over 30 over x minus 3. X minus 3 then plus c. We got 17 over 16. 17 over 16 then over x plus 3. Now, what is the smallest number here that can actually go in everyone here? That should be 1 over 30. That should be 1 over 30. That should be 1 over 30. So we are having 2x squared minus 3x minus 10 over x plus 2 x squared minus 9 equals 1 over 30 into brackets. Now, how many times can 1 over 30 go in 4 over 5? That is 4 over 5 divided by 1 over 30. They need to give us 4 over 5 times 30 over 1. So 5 here 1, 5 here 6. 4 times 6, 24. Don't forget we have a minus 6. So that's minus 24 over x plus 2. Then plus, when 1 over 30, okay. So we have a minus here, plus times minus. This actually will be minus. Now when 1 over 30 goes to 1 over 30, we are having 1 over x minus 3. Then this is plus, plus. So when 1 over 30 goes to 17 over 6, what do we have? That's 17 over 6 divided by 1 over 30. That will give you 17 over 6 times 30 over 1. 6 here 1, 6 here 5. Now 5 times 17, that should be 85. 5 times 7, 35. We write 5, we keep 3. 5 times 1, 5 plus 3, 8. So we have it as 85 over x plus 3. So this brings us to the concluding part of the question. So this compound fraction has just been resolved into partial fractions thus. So this is actually the answer. There are ways we might bring this one to the front, but it does not matter. That is, we can rewrite like, though I wouldn't want to rewrite it that way, so that there will be a reflection of the denominators. We can see x plus 2, x plus 2. Then inside this x squared minus 9, I'm having x minus 3, x plus 3. So if you have any problem related to this question, please you can drop in the comment section. Thank you.